In this video, we are going to see a few problems based on Newton's second law. So here we have got the first problem, which says the figure shows three forces acting on an object of mass 4 kg. All three forces act through the center of the mass of the object, as we can see in the picture. And it is asking us to calculate the magnitude and direction of the net force acting on the object. So magnitude means it's asking the number, which we'll get when we calculate. So we have to give a number with the unit, and we have to say whether it is left or right. That's the direction. Also, it is talking about net force, which means the total force. We have got two forces, 3 Newton and 4 Newton, both of them towards right in the same direction. So we will add them. So we get that as 7 Newton. Now let's just redraw the diagram. And this time we will write it as 7 Newton to the right and 9 Newton to the left. Now we have got them in opposite direction. So we are going to subtract it. That comes out as 2 Newton. So our magnitude of the force of the net force is 2 Newton. Now for the direction, we are going to check which one is the greater force. So in this case, 9 Newton is the greater force and it is towards the left. Therefore, the direction of the net force is also towards the left. Next problem, it's asking to calculate the acceleration of the object. For that, we will use Newton's second law, which can be represented in this triangle. And because it's asking for acceleration, we will write it as A equal F net, that is the net force, over m, which is the mass. Net force we already calculated, which is 2 Newton, and the mass we have been given in the problem as 4 kg. So we substitute that and we get the answer as 0.5, and the unit is meter per second square. Now in the second problem, we have got a problem on elevator or the lift. A woman of mass 60 kg, so m is equal to 60 kg, is standing in a lift at a shopping center. So we have got a woman here in a lift. The lift is at rest. That means speed is equal to 0, which means that acceleration is equal to 0. In the first problem, it's asking us to calculate the weight of the woman. Weight is given by m times g. Weight is also called as the force of gravity. So in case if they ask you force of gravity, then also the formula will remain m times g. M is 60, G is a constant value, which is 9.8. Remember that G is a constant value, 9.8 meter per second square. We substitute that and we get that number as 588 for the weight. Because weight is also force, so its unit is Newton. Next, what is the force exerted on the woman by the floor of the lift? For this, first we'll draw the free body diagram, FBD. Let's represent the woman by a dot, and she is experiencing two forces. One is weight. Obviously there is force of earth, force of gravity, which is downwards. And the second force is the force of the floor. The floor is pushing her upwards. But because she is at rest, the lift is at rest, that means these two forces must be equal to each other. So the force of the floor is equal to the weight, which we already calculated, which is 588 Newton. In the next part, it says the lift accelerates upwards at 2.5 meter per second square. That means it's not at rest now. We have got an acceleration for it, and that is 2.5 meter per second square. Now, again we'll draw FBD. Again, we have got two forces, but this time the lift is accelerating upwards. It's not at rest. So we show acceleration A with double arrows upwards. Floor force, the force of the floor, and the weight. Now, if you look carefully at the free body diagram, we can see that we are not drawing force of the floor. The length of the arrow is not equal to the length of the arrow which we drew for weight. Force of the floor is having a greater length because the lift is accelerating upwards. That means the force of the floor should be greater than the weight. Now we substitute this into Newton's second law. That means we are going to use Newton's second law now. F net equal ma. F net means the total force. We have got two forces here. Force of the floor upwards and the weight downwards. And because force of the floor is greater, so we will write force of the floor minus weight. Why do we do minus or subtract? Because they are in the opposite direction. Equal ma. Now we can substitute the numbers for the weight, for the mass, and for the acceleration. Then we can solve this equation step by step, and we can get the answer for force of the floor as 738 Newton. Next, let's look at the problem based on weight and drag force. In this case, we have got a skydiver who is falling at a constant speed. What's the meaning of constant speed? It means acceleration is equal to 0. First part is asking us to draw free body diagram. That means we draw the skydiver with a dot and think about the forces which are acting on him. One is obviously the weight, the force of gravity. The earth is pulling him down. And the second one is the drag force, which will be upwards, which is also the air resistance. That is the air resistance of the air, which will be acting upwards. And you can see that we have drawn both the arrows of equal size because he is falling down at a constant speed. That means his acceleration is equal to 0. That means upward force should be equal to downward force. That's why we are drawing them equal in size. Next is asking immediately after opening the parachute. Is the skydiver accelerating? If so, in which direction? Explain your answer using Newton's laws. So immediately after he opens the parachute, the surface area of the parachute is more. And that's why the drag force, that means the air resistance, will increase, but the weight remains the same as before. In this case, because the upward force is now more than the downward force, that means he is going to accelerate upwards. And as he accelerates upwards, his downward velocity is going to decrease. Okay, so that's how we explain this problem with the help of Newton's second law. Because Newton's second law says that whatever is the direction of net force will be the direction for acceleration as well. In part B, the net force is upwards because we have a greater force in the upward direction, and therefore the acceleration is also upwards.